Distant School. Cosmic Meteotectonics. Lecture number 1 describes electrical network model galaxy helioplanets background. Here we continue. There were 186 pulses of high-energy particles with energy more than 10 mega-electron volt, taken by solar isotope spectrometer in the long-term 2004 to 2014 interval. Dates are shown in Table 0201, where the number is the sequence number, year, month, day. The hour, universal time, the sign minus sign of particle rate change, plus increasing, minus decreasing. A minus and a plus meaning first decreasing, then increasing. N, particle rate change in time of PeP, energy more than 10 mega-electron volt. By a factor of n, large N, number of measurements in time of PeP, energy more than 10 mega-electron volt. Tau, pulse ratio of adjacent pulses. Table 0201 shows that pulses of high-energy particles, energy with more than 10 mega-electron volt, occurred in the Earth's magnetosphere with an average pulse ratio about 17.9 days or about 0.65 helioday over a long-term interval, from the 1st of October 2004 to the 31st of March 2014. 31 pulses of high-energy particles with energy more than 10 mega-electron volt were bipolar. Figure 0201 shows monthly Wolf numbers over a long-term interval, the 1st of October 2004 to the 31st of March 2014, and pulses of high-energy particles with energy more than 10 mega-electron volt over the same long-term interval. It is obvious there is no connection between both phenomena. Conclusions can be drawn through comparison of data from web pages and geophysical, cosmophysical, and heliophysical data. Contrastively, pulses of high-energy particles with energy of more than 10 mega-electron volt observed close to Earth did not connect with any stationary processes observed in the subpart layers of the Sun and Earth. This implies, in the framework of cosmic meteotectonics, that these pulses are the results of connections between Earth's cavity and cosmic wires. Such cosmic wires carry current inside the solar system because of its interaction with the galaxy cavity. These connections were quite short events, lasting usually no more than these hours. They did not occur every day, and were completely dependent on the state and orientation of galaxy heliocosmic geoelectrical network structures. To support conclusions, it should be noted that pulse of high-energy particles with energy more than 10 mega-electron volt, number 49, began from particle rate around 3 protons per square centimeter, and at the same time there was particle rate about 400 protons per square centimeter in the pulse of high-energy particles with energy more than 10 mega-electron volt burst. Bipolar pulse of high-energy particles with energy more than 10 mega-electron volt, number 136, shows similar behavior. The pulse number 136 began from 0.3, while several days high-energy particles with energy more than 10 mega-electron volts anomaly had particle rate about 8. This implies, in the framework of cosmic meteotectonics, that pulses of high-energy particles with energy more than 10 mega-electron volt, number 49, and number 136, had also occurred in the galaxy heliocosmic geoelectrical network structure and the prolonged anomaly of pulses of high-energy particles with energy more than 10 mega-electron volt, shown in Figure 0202 and 0203, had occurred in the heliocosmic geoelectrical network structure. Thermal crisis in geophysics is not the least factor for a deep understanding of how does Earth's interior work. Since the first quarter of the 20th century, investigators have been carrying out the scrupulous calculations of the heat produced by radioactive isotopes decaying deep underground. The results have allowed the conclusion that the reality differs from the obtained results. This is the so-called thermal crisis. Close scrutiny of Clark's, in other words, the percentage of units of isotope mass per unit rock mass, and then calculation of radiogenic heat flux, has caused a sensation among investigators of Earth's interior heat energetics. Recently, an international team of physicists used the CAM-LAND detector in Japan and the Borexino detector at Laboratori Nazionali del Gran Sasso in Italy to measure the flux of antineutrinos emanating from deep within the Earth. According to theory, the radiogenic deficit of the heat flux deep within the Earth is very high. The amount of heat flux obtained by detectors is more than predicted by the model, but much less than a total flux of 47 plus or minus 2 terawatt. Only about 50% of the heat given off by the Earth is generated by the decay of radioactive isotopes. CAM-LAND collaborator Stuart Friedman of the Lawrence Berkeley Laboratory in California says, "One thing we can say with near certainty is that radioactive decay alone is not enough to account for Earth's heat energy." He continues, "Whether the rest is primordial heat or comes from another source is an unanswered question." Thus, the theoretical model of heat flow within the Earth does not represent the reality, and a better model of its source must be developed. The question goes on to ask, what is the alternative source of the Earth's interior heat energetics? Moreover, the question is of crucial importance for the development of the earthquake foci model that can only be done after the alternative model of heat flux source in the Earth's depth has been investigated. Therefore, the assumption was grounded in the frame of the many-particle theory, non-local statistical mechanics, developed by Anatoly Vlasov, who published his main investigations between 1938 and 1978. From the perspective of Vlasov's theory, vortex models of deuterons migration, enrichment and fusion in mesoscopic cluster around 10 nanometer in diameter units of the Earth's interior were defined, formed, and investigated. A deuteron is the atomic nucleus of a deuterium atom, or deuterium ion D+ or 2H nucleus. This is a nucleus of an isotope of hydrogen, half heavyweight hydrogen deuterium, which consists of a proton P and a neutron N. Using Vlasov's theory, a model based on proton tectogenesis conception was developed. The proton tectogenesis conception was begun by Descartes through intuitive insight. He suggested the presence of solar substances in the Earth's depth, and when several centuries later researchers used spectroscopy, they discovered the Sun consisted mainly of hydrogen. Mendeleev assumed that Descartes' deep hydrogen rises upwards within subterranean discontinuities and cracks and reacts with carbon, forming hydrocarbon accumulations, oil and gas. Descartes' insight into solar substances deep underground and Mendeleev's assumption regarding deep hydrogen's role in producing non-organic synthesis of oil and gas led Vernadsky to the next step. He suggested that the heavy and solid Earth's core consists mainly of iron hydride, FeH4. Russell J. Hemley and Ho Kwang Mao from the Carnegie Institution for Science contributed to Vernadsky's suggestion about the chemistry and physics of the Earth's mantle and core. Their discoveries proved Vernadsky's idea and were the first in situ high-pressure, more than 1 gigapascal observation of the reaction between iron and hydrogen. Vernadsky assumed that hydrogen from the Earth's solid core escapes upwards within a liquid core and mantle, asthenosphere and crust, hydrosphere and atmosphere, and escapes into interplanetary space. Satellite measurements during the era of space exploration have shown that fluxes of atomic nuclei of hydrogen atoms move upward from the ionosphere to the magnetosphere. That was called a proton upwelling phenomena, confirming the proof of Earth's degassing model suggested by Vernadsky on the basis of Descartes and Mendeleev's insights. Driven by Descartes, Mendeleev's and Vernadsky's ideas about deep protons moving from Earth's core to outer space, Larin, a geologist and geophysicist, formulated the hypothesis of primordial hydride Earth. The proton tectogenesis, including sporadic genesis of earthquakes, is the main consequence of Larin's hydride hypothesis. In the framework of the non-local statistical model, the migration of the nuclear ions of hydrogen atoms, or simply hydrogen ions H+, is accompanied with deuteron migration through the displacements and discontinuities of strata in the mantle and crust formation. Hydrogen ion H+ is a proton. In other words, the atomic nucleus of light hydrogen protium atom, or hydrogen-1, which is the stable isotope. It has the smallest diameter in comparison with other hydrogen isotopes, such as partial heavyweight, hydrogen-2 or deuterium, the second stable hydrogen isotope, or heavyweight hydrogen-3 or tritium, the non-stable isotope of hydrogen, consisting of 1 proton P and 2 neutrons N. The ratio of proton to deuteron condensate is approximately 10 to the power of 4. The least displacements and discontinuities of strata in the mantle and crust formation, through which protons and deuterons pass, are called hydrogen draw dyes. More narrow displacements and discontinuities in the surroundings of the Earth's interior are called hydrogen-separating subdraw dyes. Fine but frequent protons pass through hydrogen-separating subdraw dyes. Half-heavyweight but rare deuterons are stuck in the bottleneck of subdraw dyes. Migration of isotopes of hydrogen systematically enriches with deuterons the mesoscopic cluster, about 10 nanometers across of mesoscopic scale volume, where 1 nanometers equals 10 to the minus of 9 meters of depth material beneath the hydrogen-separating subdraw dyes. When a pulse of so-called non-local statistical vortex fusion in a mesoscopic portion of deuterons is self-organizing, the deuterons in the mesoscopic cluster under the hydrogen-separating subdraw dyes is said to be in non-local critical concentration, or N and little c. Non-local statistical mechanics operate with non-local statistical distribution functions of objects and cooperation between objects by means of long-range forces of self-action. Vlasov's conception of self-action later became Prigozhin's self-organization and subsequently Harkin's synergetics. In the framework of a non-local statistical model, 3 typical fusion reactions of mesoscopic portions of deuterons in mesoscopic clusters and the energy release are given below. The reaction shows that, due to the acts of fusion of mesoscopic portions of deuterons in mesoscopic clusters, hot isotopes of helium, in other words helium-4 and helium-3, and tritium, hydrogen-3, free hot nucleons, P and N, and hard leptons, gamma quantum, are emitted, some amount of energy is released. Pulses of deuterogenic heat melt mesoscopic clusters, turning them into mesoscopic stoppers. The migration of charged condensate nuclear ions, mostly hydrogen ions or H+, is accompanied by the migration of charged condensate of molecular hydroxide ions, OH-, in the framework of the Descartes, Mendeleev, Vernadsky, Lara, Alangoa model. Hydrogen ions H+, have chemical properties of absolute acid, the destructive properties of which are much higher than those of concentrated acids, such as hydrochloric acid, HCl, sulfuric acid, H2SO4, and nitric acid, HNO3, or even its mixture of so-called aqua regius, in Latin and ancient Italian literature, royal water, or to give it its chemical name, nitrohydrochloric acid. The molecular hydroxide ions, OH-, have chemical properties of absolute alkali. As a result, the condensate of the molecular hydroxide ions, OH-, acts as a glue to join a set of mesoscopic stoppers into the entire macrostopper, capping the foci of future protonic tectonic phenomena. As the volume density of mesoscopic stoppers thickens, the macrostopper increasingly closes the gap of the migration of protons, which results in its accumulation in the mesoscopic zones of displacements and discontinuities of the foci volume of the forthcoming tectonic sporadic phenomenon. Underneath, the macrostopper protons dissolve in mesoscopic voids, dislocations and fractures at the metal grain boundary. Such grains contain metals of transitional groups, such as iron. When the concentration of protons reaches non-local critical value, then the phenomenon of extreme proton effervescence is said to be rushed in the polymorphic transformation phase, or for polymorphic proton effervescence to have occurred. Proton effervescence from proton oversaturating mesoscopic displacements and discontinuities of foci matter means the freeing of absolute acid, or hydrogen ions, protons, which destroys the macrostopper. As has been mentioned, the macrostopper caps the focus of the forthcoming protonic tectonic phenomenon. Hydrogen plays the most important role in geological processes since Earth's accretion. Modeling of the processes of sporadic proton technogenes is used to both model cosmological and planetary geological matter, and to interpret the results of experimental geology and metamorphism evolution. Hierarchical discretion of geological units extends from the sub-global unit, continental plates about 10 to the power of 6 meters in diameter, to the atomic unit, quantum dislocations about 10 to the minus 11 meters. As is known from experiments, iron samples swell up to 36% of their volume when protons impregnate the crystalline lattice. A number of investigations have been carried out on the effects on iron, steel, and other metals in the presence of hydrogen, producing hydrogen embrittlement. There have also been investigations and experiments on the differentiation of magmatic melts under the pressure of hydrogen, and the growth of carbonate rock fracturing in the presence of hydrogen, or interaction between albite melts and hydrogen. Since the 70s, 2 research groups, one in Japan and one in former USSR, have investigated other anomalous properties of metals in the presence of hydrogen. In 1980, Shapovalov's group made a breakthrough and discovered that in the presence of dissolved hydrogen in the metal, the mechanism of polymorphous transformation is changed radically. Movable, highly hydrogen-saturated unstable zones with properties very similar to those of a liquid emerge at sites between growing and disappearing crystals. the phenomenon is manifested in unusual external effects. For example, a complete loss of the shape stability of metal crystals during rearrangement of the lattice. They flow under internal forces and deform like a viscous liquid. In the presence of hydrogen, even at low pressures, iron behaved like a liquid, its samples changing shape under the effect of gravity. For example, spherical samples changed their shape in that they crept down from a fixed thermocouple, either in bulk or in separate icicles. It is worth noting that anomalous spontaneous deformation did not occur during the initial cycles, but only after a certain incubation period, which lasted 35 to 200 cycles, reducing at greater hydrogen pressures. Another spectacular outcome was the impulse evolution of protons from the metal during its lattice rearrangement. This is known as polymorphic proton effervescence. The impulse characteristic of polymorphic proton effervescence from metals and their alloys indicates the main role of the collective processes when protons permeates and saturates metals. Savchenov later reported that movable atomic metal-hydrogen clusters were being observed at room temperature. Those atomic metal-hydrogen clusters are thin disks between 5 times 10 to the power of minus 10 meters and 4 times 10 to the power of minus 9 meters diameter, and were observed at the side of tension cracking. The surface of the cracking resembles the boiling of liquid. Therefore, the clue to a phenomenological model of proton-electrical preparation of the focus and start of an earthquake is the capability of the atoms of metals to incorporate protons coming from outside into their electron shells. Such impregnation of protons causes strong deformations. Protons accumulate in a metallized trap, which is situated at some depth in the fault. Atoms of many elements, silicates, aluminium, and others, are not saturated with protons. Thus, the Seil structure riding over the metallized trap defines the confinement of protons within it. Seil, in geology, means made of silicates and aluminium. Protons do not impregnate the crystalline lattice of silicates and aluminium. Mainly, the Earth's crust is made of Seil structures. Seil structures cover volumes beneath themselves. If volume contains grains of metal, iron, and so on, then protons impregnate into their crystalline lattice. Such metal grains become traps of protons. Such metal grains hold protons. Obviously, impulses of deuteranomogenic heat work more effectively with mesoscopic stoppers consisting of mesoscopic portions of aluminium than with mesoscopic portions of iron, which has a higher melting temperature, and the matter of faults and degassing conduits is always enriched with chalker minerals containing low heat copper and tin. Therefore, focus preparation stages are cyclic accumulation of protons in the metallized trap beneath the aluminium-bronze macrostopper and polymorphic proton effervescence following the critical proton saturation of metals. The change of slow positive deformation, in other words swelling of focus, and fast negative one, in other words collapse of focus, is then connected with the embrittlement of metals in the presence of hydrogen, which causes the earthquake, in other words, to create the elastic wave propagating from the focus. Depending on the site, different phenomena manifest themselves. For example, when the startup of a catastrophic earthquake arrives, then an iron avalanche, comprised mostly of protons, rushes upwards from the foci of the earthquake through the displacements and discontinuities of depth matter, in other words through so-called proton channels. Such extreme upwards ion migration thus results in a spider's web curve of zones across the Earth's surface experiencing maximum destruction. Well, you know that seismology uses intensity distribution. Intensity decreases with distance from the earthquake. This is a theory. Practice shows that maximum shakings, Mercalli intensity scale 10 to 11, have been observed at a distance more than 100 kilometers from the epicenter, in places where maximum shakings must be only 7 on the Mercalli intensity scale, or narrow, tens meters, and long, tens and hundreds of kilometers, zones of destructions to have observed. So it is better to represent levels of destruction as a neighborhood of lines on the surface of the Earth, spider's web curve with splitting. Sometimes such an iron avalanche causes the formation of a gigantic molecular hydrogen, or H2, bubble rising above the ocean floor towards the ocean's surface. The water flowing down over the bubble's surface forms a tsunami. The water rolls down from the bubble's surface. Another consequence of protonic electric preparation of the earthquake's focus and external startup is the stages of differentiation of the substance in the Earth's interior. This is supported by the discovery of deep trails in the viscoplastic, inelastically deformed substance of the mantle beneath the deep faults extending to the bottom of the Earth's crust. This is the great achievement of seismic tomography. Interpretation reveals a deep trail has considerably greater density than the mantle's substance through which the trail extends. As mentioned, non-local statistical vortices models are used to estimate pulses of deuteron genesis heat, which is released from the foci of sporadic tectogenesis. At the same time, these models solve the problem of helium ratio in the Earth interior. This problem was called the outstanding discovery of the second half of the 20th century. As is conjectured by traditional or conventional geophysics, the alpha decay of isotopes, that's radioactive decay, in the Earth's interior is the source of naturally occurring helium-4 on Earth. It is also conjectured that deuteron, DD nuclear fusion reaction in the Sun's core in deep layers, is the only source of occurring helium-3. The measurement of helium-3 and helium-4 ratio over many years reveal that the average ratio is approximately 1.4 times 10 to the minus 6 in the Earth's atmosphere. Such ratios, measured in volcanic gases on Kamchatka by geology laboratory researchers and the Precambrian era of Academy of Sciences of the USSR, were much greater than in the atmosphere. These results were widely doubted and caused a stream of measurements of helium ratios in rift zones, where there are channels across mantle surface. A high concentration of helium-3 in mantle fluxes was thought to have been caused during the creation of our planet from proton dust clouds, swirling around the proto-sun, that is to say, it is primordial nuclide. However, in the standard model of Earth's evolution, how does one deal with the fact that helium concentration ratios became averaged in all geospheres, in the Earth's core and mantle, in asthenosphere and the Earth's crust, and in hydrosphere and atmosphere in 4.5 billion years of evolution? This question is not answered in publications concerning primordial isotope helium-3. Therefore, the origin of helium-3 in the Earth's interior can be identified as a result and validated by theory and experiment of non-local statistical vortex fusion of deuterons in the Earth's interior mesoscopic portions of the substances enriched by deuterons. The theoretical and experimental basis of the non-local statistical vortex fusion of deuterons was formulated by Dmitry Kuznetsov and published in Vortex branch of Non-Local Statistical Mechanics for Astro-Cosmo-Geophysical Tasks, non-local vortex impulse cooperation of deuterons resulting in neutron flux under cryogenic conditions. Petropavlovsk, Kamchatka.